Solar or nuclear? Which is the best energy source? Energy is one of the most fundamental things in the universe. As we've discussed before, energy is essentially the currency of the universe. You can earn it, spend it, and convert it from one form into another. But just like destroying real money is illegal, destroying energy is also impossible. Energy cannot be destroyed, only transformed. Because of this, the universe's entire economy runs on energy. Stars remain stable by balancing gravity with the energy released from nuclear fusion reactions. Plants convert radiation energy from the sun into chemical energy to produce food. Herbivores eat plants and release that stored chemical energy to generate the kinetic energy their muscles need. Even biological evolution itself operates according to an energy economy. If you think about it, individuals we call advantaged or disadvantaged in evolution are simply those who use the energy they can produce throughout their lives in more or less efficient ways, given their genes and environment. Energy is not only essential in physics and biology, but also in culture and civilization, which are extensions of biology. Our cars, computers, airplanes, factories, homes, everything you can think of depends on energy in one way or another, and I'm not just talking about electricity. Even before electricity, all systems were ultimately powered by human muscle or brain energy. The pyramids were designed by the human mind and built by human labor. A pharaoh without enough manpower, in other words, without sufficient potential energy, could never have built a pyramid. Energy production is so vital to civilization that in science we often measure how advanced a civilization is by how much energy it can produce. Major energy sources. Today, we rely on 8 major energy sources: coal, natural gas, hydroelectric power, nuclear, wind, solar, oil, and biofuels. There are also geothermal, hydrogen, wave, tidal, and waste fuels, but combined, they barely make up a noticeable share, so I'll ignore them for now. These energy sources are not equal. They differ in several critical aspects. 1. Energy density. One of the most important factors is energy density. How much energy we can produce per unit mass or volume of fuel. By far the most energy-dense source is nuclear energy, the enormous energy trapped inside atoms. Just 1 kilogram of uranium-235 can theoretically produce around 80 million megajoules, and in practice, about 4 million megajoules. For comparison, coal, oil, and natural gas produce only 20 to 55 megajoules per kilogram. The difference is enormous. However, this extreme energy density is not always an advantage. Most power plants ultimately work by boiling water and spinning turbines. Using uranium just to boil water is, in many ways, overkill. As a result, much of nuclear engineering is about controlling this immense energy release, which increases both cost and risk. Still, that same energy density makes nuclear power extremely efficient. A small amount of fuel produces a massive amount of energy. In contrast, to generate the same amount of energy from hydroelectric, solar, or wind power, enormous volumes of water, photons, or air molecules must pass through turbines or panels. These are much looser energy sources. They only work at scale. 2. Stability. The second critical factor is stability. Can we produce energy whenever we want? This is measured using the capacity factor, which compares the maximum possible energy a source could produce if it ran at full power continuously to the energy it actually produces. Nuclear power plants dominate this category with capacity factors over 90%. They are extremely stable, producing energy day and night, summer and winter, regardless of weather, except during maintenance. Natural gas plants, even in combined cycle systems, struggle to reach 60%. Oil performs terribly, with around 10%. Solar and wind depend on sunlight and wind, so they cannot produce energy during cloudy or windless periods. Solar panels, for example, cannot produce energy for at least half the year because half the time it's night. When weather is included, capacity factors can drop as low as 10%, usually averaging around 20%. 3. Resource availability and sustainability. The third factor is how abundant and sustainable the fuel source is. Solar, wind, and water clearly lead here. These resources have existed for about 4.5 billion years and are effectively unlimited. Nuclear energy is more complicated. On land, we only have enough uranium for a few centuries. Uranium also exists in the oceans, but extracting it is extremely difficult. If that process became efficient, we could theoretically access enough uranium to last around 60,000 years. 4. Climate impact. Another crucial factor is climate impact. We know with certainty that greenhouse gases like carbon dioxide and methane cause global warming, destabilize the climate, and make our planet increasingly uninhabitable. If we can't live on this planet, producing energy becomes meaningless. To measure this, we use carbon-equivalent greenhouse gas emissions per gigawatt-hour, accounting for emissions across the entire life cycle, from construction to decommissioning. Surprisingly to many, nuclear power ranks first, emitting only about 6 tons of CO2 equivalent per gigawatt-hour. Nuclear power is an extremely clean energy source. Wind and hydro are also very clean. Solar, however, emits around 53 tons, largely because manufacturing solar panels produces significant emissions, even though the panels themselves emit none during operation. The worst sources by far are coal, oil, and natural gas, which is exactly why we are trying to move away from fossil fuels. Unfortunately, current usage rates show we still rely heavily on them. So, which energy source is the best? If your answer is a single source, nuclear or solar, then your answer is wrong. Scientists see 2 key conclusions from this data. First, no country should rely on a single energy source. None are perfect, and none are entirely useless. Energy diversity is critical for national security and stability. Countries need short, medium, and long-term plans tailored to their geography and resources. Second, public perception of energy sources often does not align with scientific reality. If we ranked these sources using green for strengths and red for weaknesses, nuclear energy would score the highest overall. Wind, solar, and natural gas would follow. Coal, oil, and biofuels would rank last. Hydroelectric power would sit in the middle. These are objective facts, yet in public discourse, nuclear energy remains heavily stigmatized. Yes, nuclear plants are complex and expensive, and they must be built with extreme care, considering factors like competence, security, war, and terrorism. But dismissing nuclear energy solely because of Chernobyl or nuclear waste is not supported by the data. At the same time, no country should rely only on nuclear power. A small number of nuclear plants can supply most of a nation's energy, but they also create vulnerability to war or sabotage. Additionally, limited uranium reserves could create dangerous geopolitical dependencies. Therefore, countries should prioritize energy sources they can produce independently within their own borders. Wind-rich regions should build wind farms. Sunny regions should invest in solar. Nuclear power should be included as part of a diversified energy strategy where feasible. Fossil fuels should be phased out carefully, not abruptly, because modern energy systems are still built around them. Without a serious and honest energy transition plan, abandoning fossil fuels for symbolic reasons can cause severe economic and social crises. Ironically, those crises may push societies back toward even dirtier energy sources. Energy is not just a technological issue. It's a biological issue, a psychological issue, a sociological issue. In short, energy is a problem for all of science together.